Good day, and welcome to the demonstration of RoadPlus 8, the program for automatic lighting calculation for roads. RoadPlus is a module that allows you to calculate many roads, linear roads, at the same time. So it means that it can be used, for example, whenever you have to perform the calculations on a huge set of roads to calculate. And this will be done automatically by the program. So this is the case, for example, whenever you have to study the whole city. And so you have different roads or different sections. But it may also be used to calculate the best performances of luminaires, giving different sections and using different photometries, for example, corresponding to different photometries or for different currents, driving currents. The main point is that all the module is based on an Excel file. Let's pay a look to the Excel file. So this is the Excel file, and let's analyze the different sections of this file. First of all, the file folder settings. In this case, you have to define where you want to save the projects and where you have located the photometries that the program is going to use for the calculation. Then let's analyze the different sections. So the first one is the project reference data. This is the section type, the street and stretch. So in here you can define exactly what are the references of your road. Let's consider that the first, second, and third column will then be used also to describe the name of the project. But we come back to this point later on. The other section on the right is the road and luminaire parameters and data section. So the first one over here, it is the one related to the carriageway. The first column is related to the class. So in this case, you can see M4. This is the class described at the European standard EN 13201. And this is the class to which corresponds a well-defined value of luminance. In this case, it is 0.25. But then the same standard is describing that it is possible to reduce the class. So, for example, the class M4 is the class for the road for the hours, let's say around 8 o'clock in the evening up to midnight. But then after midnight, when the traffic flow is going to be reduced, then we can move from M4 to M5. So in this case, we can define how many steps we want to reduce our class. So in this case, when we say 1, the program will automatically, whenever we start the process, the calculation process, then it will automatically expand and create a second line, giving and inputting here the class M5. This is brand new compared to the previous version, the 7.0 version. Next column is the tolerance on luminance. So the designer may define a tolerance on the value defined by the standard. So for example, if you want to give a little more space to the luminance level in order not to come too close to the limit, because our standard, the EN13201 standard, is saying that you cannot go below. You have to constantly keep the same value forever, and you cannot go below. So in this case, you can define a tolerance. And this is also brand new compared to the previous version. Then the R table. So let's say the characteristics, the reflection properties of the asphalt, of the cement or asphalt of the carriageway, and the Q0, the coefficient of reflection. Then next section is the one related to the sidewalks and parking lanes. Again, we can define the class we want to use, and we define in this way in this case, the luminance value that should be confirmed after the calculation. The tolerance, again, with the same concept as before, and the reflection factor of the surface, because in this case it is not considered as a irregular reflecting surface. It is a diffusive Lambertian surface. Next step is the layout, the road layout. So the first one, the first column says to us if we have to define a one-way lane or a two-way lane. If we define yes, so if we have a carriageway with 2 lanes, then we define with yes that the direction, the moving direction is always the same. Why? If we put no, then one way will be in one direction and the other one will be in the second direction. Then here we define the transversal dimension of the different section of our road, considering the sidewalk, the parking lane, the carriageway. In this case, we input the complete width of the carriageway. In this case, we have 7, and number of lanes 2. It means that any lane will be 3.5 meters. Then we can define the central reservation, and on the other hand, we have the second carriageway with the number of lanes, and again, like it was over here, we have the parking lane and the sidewalk. At this column, we have the total width of our road. Again, another section is the one related to the luminaire data. So, how we install the luminaire. So, the height, the spacing distance, the tilting angle, the luminaire carriageway edge distance, the maintenance factor, and the lighting factor. So, height is the height where you install the luminaire, or exactly, it is the height where you want to place the luminous point, the luminous center. All these parameters, as you can see, they are parameters where you can manage the ranges. What does it mean? It means that you can ask the program to calculate with a height of 8 meters, but you can also write that in place of only having 8 meters, you may also consider 9 meters. So you write 8 dash, like it is mentioned over here, where you have, for example, 5.5, 7.5, and 8. But it is also possible to define with the brackets, the square brackets. You can say 6 to 10 with a step of 2. So the calculation will be performed at 6, 8, and 10. So you have different options to define the ranges. So you can understand how it can help you to search the proper solution, the best solution, in order to have the proper and better light distribution. The same with ranges, it is for the spacing distance and for the tilting angle and for the luminaire carriageway edge distance. Then we have the maintenance factor. The maintenance factor at the previous version was not defined as a range parameter. Was not defined as a range parameter. It was a fixed value. But now, following the request from some of our customers, it is now possible to define ranges also for the maintenance factor. You can see that the new Excel file, the one related to version 8, it is possible to have this section, this cell, where you have the comments about what was changed. In this case, with the blue one, we said that it is a modification of the previous version, while in this case, it is a new column, and over here we have the description of the lighting factor in this case. So the lighting factor was introduced following the request of some designers, because they do not want to manage the class reduction we had a chance to see before, but they want to have a fixed value they want to freely manage. Next step, the distribution. So we can say over here where we want to place the luminaires, on which side of the road we want to place the luminaires. Then the photometric name. And this is a key point, the photometric name, because you can input here the usual file formats like LDT, like ISO, or like OXL. We have to say that Road Plus 8 is including now a brand new optimization feature. So it is a feature that allows you to ask the program to exactly find the proper solution to better achieve the luminance value that we defined before with the classes. So what does it mean? It means that with the OXL files, it is possible to input the driving currents. So it means that we have exactly at one file the flux and power in function of the current curves, so that the program can work on these curves and find exactly the best solution for the calculation. So let's say that, let's analyze the different files. So over here, we have the photometries, and as you can see here, we have 4 different OXL files. In this OXL file, we have the first one is for one module. This is a luminaire with one module. The second one is for 2 modules, then for 3 modules and 4 modules. But how are these files based on? So if we open Photo View and we come back and select one of these files, we can see that the OXL file is carrying the flux and power in function of current curves, as you can see here. So the points are exactly the values coming from the, in this case, the LDT files supplied by the manufacturer, which are here. So this manufacturer is supplying, as you can see, 60 is 600 milliamps. So it means that one module at 60 milliamps, but then we have the same one module with 62, the same one module 64, and all over up to 180. So in this case, we may let the program calculate on all these photometric files in order to find the best solution, and we'll see then how to manage it. But on the other hand, we may input all the different values over here, and the program will automatically create the curve based on a polygonal of segments, as you can see here. And this is a method that was described at the brand new standard, the IC 62722-2-1 at the Appendix C. And this standard was introduced this year, 2023. And it is saying that it is possible with a best resolution, a very good resolution, to define segments, because the curve has a concavity downward over here. So the segment is always below the curve, the real curve, while the points are exactly on the curve. And so in this case, we have a very flexible, very simple way to define the curve, and then we can use it to optimize the calculation in order to find the best possible solution. We'll come back after the calculation. But you can imagine that also from the point of view of the calculation, calculating on 240 fines, it is a biggie. While calculating on 4 fines, it is much quicker. Okay, let's go back to the Excel file. Then we have the product code. If you want, you can input here exactly the product code. But at the end, this is a column that it is rarely used because usually the code is coming with the photometric files. Then the IP, EI, and A, these are some parameters for energy assessments that were introduced over here in Italy, and they're very useful and very simple to use. And in here, you have to define the area type. So road, cycle, pedestrian path, etc. And the program, we use this one to define at the end the proper IPEI and A energy efficiency assessment in function of the Italian standard. Over here, you can define, do you remember that we already defined at the beginning that it is possible through the first, second, and fourth column, it is possible to create the project file name. But over here, if you do not want to use this file name created by the conjunction of the description of the first column, second column, and fourth column, you can define over here the project name. So whenever you have different solutions, for example, in this case, the program will calculate with 2 different classes, then the project name will be the same, but in order to distinguish the 2 projects, the program will automatically add _01, _02, etc. So this is the latest column for the input data. From here onward, on the right, we have all the parameters that the program would manage to define the calculations in different sections. So the first one is the log. It is the log, so it means it is where the program is writing the description of the error in case some error will appear during the calculation. Then in here, the program will write the project name so that you can easily search and find the project. And over here, the parameters for the sidewalk 1, the parking lane 1, the carriageway 1, the carriageway 2, on the other hand, after the median in case, the parking lane 2, and the sidewalk 2 results. Okay. 3 latest section. The first one is the energy efficiency assessments, where we input over here the parameters, the energy efficiency assessment from the Italian standard. It is Italian standard, but it is also a mandatory law over here in Italy. Then the value, the interdistance height, the DP, it is calculated in function of the European standard for road lighting. Then the Q installation, the UF, utilization factor, and the overall efficiency. At the end, we have the luminar flux, the luminar source flux, in this case, the power consumption, and the driving currents. So we will find here exactly, using OXL files, we will find here exactly the value of the driving current corresponding to the achievement of the luminance value defined at the selection we did through the class, the road class. Let's say that in case of running the calculation using LDT files or ISLM63 files, it is not possible to define the current because these files are not managing the driving currents. So whenever you want to manage driving currents and running the optimization feature, it is absolutely necessary to run it using OXL files completed with the driving currents we had a chance to see before. So this one. Then we have the luminous intensity glare parameter, G asterisk, and from the same standard, the glare index, D, for area lighting, then the downward flux fraction, the UL, following IS TM15, and the same, the other parameter, UH. These are the two parameters that are brought through the Italian standard for energy efficiency assessment, but also for our load. Then, if you want, you can also input the price. Why? Because many customers of ours are now using the Excel file. Whenever it ends with the calculations and with all the results, then this file is used at other applications in order to manage the information, also through other applications. Latest column, and this is a brand new one, like the current was a brand new one. This one is allowing us, whenever we finish the calculation, to select which calculation should be printed. So in this case, you have to put over here an asterisk and run again the process selecting the output file. Why? Because at the end, the program will always create starting from the input file, an output file that you may save with the printouts information. Let's say that it is also possible through the Road Plus feature to select if you want to print to PDF, print the report. But in this case, any calculation will be saved to PDF, will be printed, the report will be printed. But in case you have 5,000 calculations and you don't want to print all of them, but only those corresponding to the needs, corresponding to the satisfaction of the standard, of the lighting standard, then you may use this feature. So that's it. This is the Excel file that now we are going to use for our calculation. Once we have finished, we have to close and save the file. So the file is this one. So we come to LightCalc. We select Advanced Project for Roads. We select Automatic Road Calculation, and the Road Plus window will appear within a few seconds. Now we have to select the Excel file we want to use. So it is Road Plus Demo UK. This is the one we have been where we have been working on up to now. We select it. The program will automatically create the output file. Why? Because we don't want to use the input file that may be used in case in a second step. So it is much better to create and manage a second file that will be saved using the same name, as you can see, where we had out. So now the open file feature should be selected now in order to open the Excel file. We say that we don't want to save to PDF for the moment. Once we have opened the Excel file we have here, then we have to expand the macro. if you remember, we define a reduction class of 1. So it means that the program should create the second line with same parameters, but replacing M4 with M5. So let's expand the macro. And automatically during the expansion, the program is also including the photometry, because if you remember before, we input here at this column, we input asterisk.oxl. So the program is considering all the 4 photometries and then the 2 different sections of road with the 2 different classes. So we have 1 module, 2 modules, 3 modules, 4 modules for the M4 class, and 1, 2, 3, 4 modules for the M5 class. Now we are ready to start with the calculation. So let's do the calculation. And you can see that the program automatically starts to write results at the related sections, one by one. As you can see, the calculation is running very fast, and let's say that around 20 seconds we did the whole calculations. So let's now analyze the results. Over here, we have the results that the program calculated. And as you can see, this one is not is a solution that is not satisfactory for the limits. So we said that the luminance value, the minimum luminance value corresponding to class M4 should be 0.75 plus 5% tolerance. So it means that we are around 0.79. But using the 1 module luminary, this one is not achieved because the maximum luminance value that we can achieve is 0.63, which is below. So automatically the program says, red, it is not satisfied. But over here, as you can see, whenever we come to the second module, we have a calculation exactly at 0.79, like the second line. So it means that this solution is completely satisfied. So we exactly come to the 0.79 solution. This one is corresponding to the 4 module calculation. But as you can see, it is satisfied because we are above the luminance limit. But we are at 0.91, which is too much. Why is it too much? Because we used the 4 modules luminary, which has a minimum flux value, which is corresponding at the end to 0.91. And it shouldn't be satisfied because we are too far from the limit. So we are using much more energy than the one really needed. So over here, you can have through this column exactly the description of the different parameters and the calculation that was performed. So any parameter is completely satisfied. This one is not satisfied for the luminance value. But let's come to the latest column, the one corresponding to the driving currents. So, as you can see, this one is has a driving current calculated by the program 180, but 180 it's the above the top value, and we can see it over here. This is the one corresponding exactly, the OXL corresponding to the 1 module. And as you can see, at 180, we have a total of 4,730. And we are here. We are here. We are at the top. But as we could see, we come to a luminance value of 0.63, which is not satisfying the needs. But in this case, we can go down with the two modules, luminaire, we can go down to 107 milliamps. And in this case, we have a total of 40.14 watts. While using the three modules, we are at 39.14, but a driving current of 70. In this case, we are in the other case related to the one module. This is too high. The values are too high, and even though we are at the lowest driving current value setting, we cannot satisfy because the flux is too much for the needs. In this other case, we can see that going down to M5, the one module it is corresponding to the needs, but also this one, and also this one. But this one, it is also in. So, as you can see, through this analysis, we immediately have the chance to find the best solution, the proper solution in any case. And it is not like running a total of, do you remember? We had 244 ULUMDAT files that if we multiply by 2 have come to a total of 488 files. And as you could see, roughly a calculation is running a time of roughly 3 seconds. And in order to calculate this solution using the OXL file, we needed only roughly 20 seconds. But if we consider 488 by 3 seconds exactly, we come to a total of roughly 40 minutes. But then you have 500 lines that you have to study, and you have to define one by one, which is the proper solution. Using the optimization feature, we come exactly to the point we need in a much quicker way. The Excel file may also be used as a synthesis of results that you can put in your file, because let's say that whenever you have to study a whole city, then it means that you may have, for example, for a city like Milan, there are thousands of calculations that were performed. Once in 2015, the lighting of roads were replaced for the Expo. The lighting was replaced with LEDs. So it is a biggie if you have to open, in case of analyzing, you have the need to analyze again the project. It is a biggie if you have to select the project, open the project. Why? If you have the Excel file, it is much quicker, because you open the Excel file, you select the road, and you will have all the results in very short time. So let's say that the Excel file may be used as a file where you store the information related to the lighting of a city, but also, on the other hand, may be used by the manufacturers to study the proper solution for the luminaires in function of different sections that they may define. So, for example, you study the luminary, you define a photometry, and then you can easily and automatically, let's say, analyze if the luminaire under consideration it is suitable for, let's say, an interdistance of 20 meters, 25 meters, 30 meters, etc. And the program will do that for you in an automatic way.